Hello friends, my name is Ashutosh Gupta. I am a software engineer. I have 4 years of experience, right? So I so we will discuss this system design problem of how to design a device backup application, right? So I was asked this question in a interview of Amazon for SD2, right? So let's deep dive into it. What is the question and how I approach the problem, right? So the question is that I have to design a backup system which take backups of apps, phone book, etc. So whenever you switch a phone from one phone to a new phone, there will be some kind of a backup through your email. You do a backup, right? That let's suppose if you are converting from one mobile, right, mobile one to mobile two, the migration of the data that happens, right? So this from here this backup device system application that will help, right? So we have to discuss about it, how can our design our problem and what are the things, right? So let's quickly jump into it. That so let's start with firstly with the functional requirement. What is the functional requirement we are giving, right? So so the functional requirement I was given that first that it it should be, right, any type of data, any type of data here, like apps, mobile apps or Android apps or phone book, right, etc. And phone book we can do add and edit the phone book whenever you add some phone number, right? And we have a lot of user base. So let's suppose that we have uh, 10 million, 10 million of users we are having, right? So the functional requirement is mainly so what the functional requirement generally is, what are the things that your app support, right? So any app phone book you can add, right? Apps backup also you have to support, right? Then after it should be um, on a daily basis, right? On a daily basis, uh, on a daily basis uh, you can sync, right? You can sync the data at every some certain time, right? And yeah, so this is the mainly the functional requirement that I have given. It's a very clear and the simple one that I have to design, right? Then so what what we have next to do is the capacity estimation, right? Capacity estimation that I have done, or you can show that the back of envelope, right? So what should be the size, what should be the memory, how is the concurrent request, how much the latency part, and all those things we have to decide, right? So what I have asked the cross question about the size part, that each each user, how much is the size you are supporting. So he said that about 1 MB for simplicity. He said ki from 1 MB you can suppose per person can save up to max, right? So for the capacity estimation part I have done the calculation. Let's suppose we have 10 million, and so 10 million users, right, into 1 MB. So as you know from the capacity estimation part, if you have learned that it is like KB, MB, GB, right? So and whenever multiply you can do the vice versa, right? So if you are started with KB, so it is 1K, right? Any 10 what is today is at 10th power, let's thinking out loud so that you can understand also. So 1 MB is like 10 to power 6, right? And 10 to power 6 MB you are doing. So MB, KB, MB. So what you can say is that it was 6. So MB converted into GB, now GB converted into TB, right? So it's like 10 TB, right? Sorry for the confusion. Yeah. So it helps to remind of the chart that I follow. Mainly in the book itself you can learn. So sorry, so mainly the book in the learn that you can learn it this way, like how the capacity estimation work is, suppose it is like 1 kilo 1 kb as 1000 is like this 1 kb. Similarly if you write kb mb, so 1 kilo 1000, now there is 1000, then it is 1 million, right? So it will be 1 MB, right? Similarly if it is 1 million, then 1 TB. Now about the, so 1 TB of size, 10 TB of size we need, we can think about that overall. And then about the concurrency and the request I have said. So let's suppose there are two type of operation, right? Two operations here mainly. First is the uh, when you sync the data and when you update the data, right? So what is this application? It is we have to write here that it is write heavy, or say that it will always be, or let's take the use case what we have. You have switching the phone from one book or those to different, one device to different device, and then you will get the data. That is the one time, right? And other time you don't need to push it, get it, right? So I will say for now that we are syncing. So it's like a heavy, right? I will say. If you have confusion, let me ask comments. Okay. So why it is a write heavy? Because you will syncing the data in the DB. ठीक है. Let's it is not on the capacity estimation, it will come. So let's suppose the QPS part, how much the read and the write we have defined, right? Let's suppose read where read will be how much. Let's suppose you change a device how many times, so it will be 100. You can say about the 100k or 10k, right? Or we have 100 million users, will have max 100 million mobile phones, right? And 100 million mobile phones are syncing, uh, are writing, sorry. So we are writing on the every morning. Let's suppose the 6 a.m and 12 a.m, some kind of a thing we are writing to the database. So let's suppose 10 million phones I am taking approximate per day. So per day I am, per day if you do the approximation, it will be 10 to the power 5 kind of a things, right? So it's like a per day, or you can say that I am just uh, per hour they are doing it. So I'm just dividing by 10 to the power 3 kind of a thing, then it will like a 100k, right? 100k request. Or for simplicity, let's convert it into 10 to the power 5. So per day these many per day if you do, so 10 to the power 500, right? 100 times in a per day, per second 100 times. So query per second we will have, right? And max UPS is like double of current, so I'm taking a 200. query per second. Read will be very much less, right? So I can make an assumption that QPS of read is, let's suppose, 10. It will be hardly query per second, like a 1 2 QPS, right? Making assumption, right? So this is the capacity estimation part I have done. uh, Now what we will do is that we will think about the basic basic design. Then we can think about how the flow. So what I generally do is that I will do flow design. I do, okay, how the entity will work, how those things will work, right? So firstly, what I have done is that I've discussed about the part, right? So the first thing is, first let's do that it is our device, right? And we have a what we can say that this is our internal load balancer. I mean, this is a public load balancer, right? So I can write here as a load balancer, right? So this is the load balancer, this is our client side, right? And what is our service, right? So I'm making a simple service here, right? So this is our service. So let's call its backup service name. So the backup service will take two type of operations, like push and, I mean, the write and the get method, right? So as the QPS is very high, uh, I thought, because what in the design that mainly used to happen, that if a lot of aggregations and lot of things is happening, so what we generally do is to add some kind of a queue, so that it can scale up, the system is scale up, right? So whenever any write operation at a heavy it comes to our site, what we will use to do, right? We will use to make a kind of a queue kind of a thing, right? Where you will emit those events that has come, so that it is scalable, and we have a lot of worker that will run, right? So we have a lot of worker that will run, that will process, sorry, that will process those uh, events, right? And publish. Ultimately there will be a tb, then they publish, right? So I will just quickly round here. So it's a worker, and here it's a database. Now, okay, so this is the mainly flow that I have made. We will get back into it after the uh, other things design. So the main question that I was asked also, that decided that choosing of the database, right? So here is the tricky question that you have thinking. So first thing first that I have thought about it, that the data that will be there, it's not very structured. It can be key value, it can be something like that, right? Because it's mainly a name list, bunch of list of apps, bunch of list of, so what is the data? How is the data looking? So data is looking like a metadata kind of a thing, right? Metadata, list of apps, and list of phone contacts, right? So these are the things mainly. So what I think, that we can use like a NoSQL, right? NoSQL kind of databases, right? So we can do that, but think about a little much. why do we need a NoSQL database? Can there be some other databases that we do, right? So because what we are doing is that we are generally bumping all the data to the at a once and a day to the our database, right? So we don't really care about the structure, right? Because what we knew when we are giving a get method is that we will pass the device ID and device information and we'll get the data. So we can use, I can't, there will nothing like 100% correct or wrong, but here we can use like a document, or document DB is NoSQL is also document. We can use like a S3 here, right? Why S3? You can do that. First, S3 is scalable, no issue on that. Availability part, the AWS make sure that it is there, so we can rely on that. Replications we can set there also, so there is no any data issue. And during the get method, right, you can do by defining the like a file system architect that they work, right? So a lot of get methods also, it will be lag, but it is not, it, but as you need for dumping data unstructured, it is, I think it is good in a JSON format, we can save that. So choosing a database here is a tricky part, that I must say. So this is the part I lagged at the interview, because I go with the NoSQL database. But when I think about the problem statement and those things, the structure of the document, the key and the value, the index that we want to do, is not really that we are much care about the structure of the database, right? A structure of the data. We will go into the structure of data and all those things. So this is the main thing, that here I have to use the document DB, right? Or like a S3 file system kind of architecture, right? So let's now quickly go into the database designing and all those things, because that is also a important part here. So how we will structure, there can be a list of phone numbers, right? So I don't want that also here in a user table, right? So this is the mainly thing that or some additional info we can save there, but metadata, but I'm ignoring that part, right? So I'm doing a normalization kind of a thing, right? But let's suppose I'm coupling with the phone number for now, right? User ID, and there will be a device ID, device name, and here will be a user device ID, and inside device, so there is a unique device. Now there will be a list of apps and all those things, right? So that will ultimately store in our database S3 file, right? So S3 file structure will be like this. I'm making, so it will be a JSON kind of a thing, right? So by the user device ID it will be unique, right? And there you can make that the apps, list of app1, app2, right? This one, similarly phone, phone book is also there, right? Phone. So what it used to do, that at a, whenever you are doing a sync job, right? So you just dump all the data with this, replace with this. No need to just query each and every phone. So therefore we used S3 file. If you have to argue that why we have done this with S3, that you forget about the data part, what is inside it, because the mobile, whenever it's deserialized, it will get to know, right? When you're updating it, whenever you add up one of phone number, it will just take all the data from the mobile and dump it here, right? So this is the part, right? So why I have made a device here is the also the question. Let's suppose a client can have a multiple devices. So whenever he selected the email, which email, then you can have an option to select multiple devices, right? And then he can go to know. So let's now quickly jump into the API structure, API design part. So first is that write. So we will follow the REST API. So REST API will follow the post method. So the post method is like I am saying that we have a endpoint app slash v1 slash, right. Let's suppose we have a system and user want to onboard, right? So user slash sign up, the body, request body, we can pass all those data, right? Email, phone number. Then after that we can make assumption here, like you are, once you are backing up, right, user id slash backup, right? So what you will pass in the headers, you can pass token, right? From there we can extract the user also, so no need for there else a user order. And we have a backup, right? So in the body we can simply pass the JSON format that you want to do, right? Or here also you can pass a device id, right? So overall you will get a crux of it, what are we are trying to solve. So this is the first is the signing up, second is the backing up, right? And similarly we can make a get method for getting a device, right? So we have get backup through the token and device id, we can pass a response. So this is the mainly the design part, and the API design I make, DB design we have discussed. We can think about, now we can discuss much deeper about in detail. So what I have done, that let's suppose a sync method is happening, so it is at a daytime, so it can be a bulk job, right? A lot of requests will come here, so therefore it will be a scalable system, right? In the S3. Now suppose we want get query, right? So do after the we have a service to get a method to internet both get and post method, right? So I think it will work. It should be also a microservice kind of a thing, so that I mean it can be also a write query also here, right? Right. So this is all get query for write query. For get query you can also directly through the brand service you can call, either you can cache, but I don't think so there is a need for cache. We can just simply wait some time. So this is the overall design and those pictures. Let me know in the comment, or if you have any doubt or any discussion you want to know. Thank you.